Today I will explain the reactivity of haloalkane. In that, first I will explain the substitution versus elimination, that the what factors are required to get substitution or to get elimination. Second, I will explain the SN reaction mechanism, and the third and the last I will explain the elimination reaction mechanism. Now, number one thing, what happens when heating the haloalkane under reflux with sodium or potassium hydroxide solution? So right now this is the simple bromoethane. If we just add potassium hydroxide to it and if we just heat it, so what do you think what we will get, what will happen? Okay, now we could get alcohol, a substitute product, or we could get alkene eliminated product. So here, so what decides whether you get substitution or elimination? Okay, now remember that in all cases you will get a mixture of both reactions happening, some substitution and some elimination. What you get most of depends on a few factors. Number one factor is the type of haloalkane. So if you are using first degree alkyl halide, so you will get mainly substitution product, and third degree mainly give you eliminated product. But when you will use second degree, it will give you both type of product, mostly equally. I would say equally it will give you both type of product. Okay, now second factor, I would say the second factor is the solvent. If you will use water, then the substitution will occur. If you will use ethanol, then the elimination will occur. Now the third factor is the temperature. The lower the temperature, the substitution will occur. The higher the temperature, the elimination will occur. And the last factor is the concentration of sodium or potassium hydroxide solution. Okay, when the concentration will be low, then you will get substitution product, and if the concentration will be high, then you will get eliminated product. So these are main four factors you have to remember. Then you will going to decide whether the substitution will occur or whether the elimination. Okay, now I will explain the SN reaction and the elimination reaction with mechanism. Okay, now I will discuss the nucleophilic substitution reaction, and nucleophilic substitution reactions are also two types. The first type is called SN2 reaction and the second type is called SN1 reaction. So we also call them as nucleophilic substitution reaction bimolecular or nucleophilic substitution reaction unimolecular. So mechanism of the both type is different, so I will discuss one by one. First I will discuss the mechanism of SN2. Okay, for that first I will draw the structure of alkyl halide. Now let's suppose carbon is bonded with halogen, and right now I am just representing halogen as X, and we can also call this as leaving group because during the reaction this halogens get removed. Okay, and in place of this X there could be chlorine, bromine or iodine could be there. Okay, now and this carbon may be attached with four different group, or maybe it could be attached with three hydrogens. It could be attached three alkyl groups. So it could be primary, secondary or tertiary. Right now I'm just writing R1, R2, R3. Okay, now this is a simple structure of alkyl halide. Okay, remember that because of electronegative halogen comparatively to the carbon, they halogen are highly electronegative, so there will be a partial negative charge. On the carbon there will be a partial positive charge. Okay, now we will talk about the nucleophile. So we are reacting this thing with nucleophile. Okay, so do you think the nucleophile can attack from this side or should it attack from the back side? So what do you think? So the first option is wrong. The reason is that in front of here, so we can say here, because of the negatively charged leaving group will repel this nucleophile. So I will erase that thing and let me draw it properly. Basically the nucleophile will come from the back side, yes, and it will attack on the partially positive carbon. Okay, now what will happen next? The nucleophile will be making a bond with the carbon, and the leaving group will be leaving the carbon. The both thing will be happening on the same time, but all the other group will be attached with the carbon. There will be no change in that group. Okay. Now can you analyze this state? This state in which a carbon is bonded with 5 groups, so we call this state as transition state. Okay, now this state practically doesn't occur. Now what will happen here? So we will get our product, that is the nucleophilic substitution product. The nucleophile permanently attached with the carbon along with other groups that were attached to the carbon, and the leaving group will leave the carbon. Okay, now this is the simple general mechanism of SN2 reaction. Okay, now let's talk about more about this mechanism. Now, number one thing we have to remember, the whole reaction is done in one step, and the second most important thing is that how many molecules we can find that are involved in a single step. Now the first molecule is the nucleophile. This is the first molecule, and the second molecule basically it is itself alkyl halides. So this one is the second molecule. So when we write the rate equation for this equation, so what we will get, the rate equation will be written in this way, that the concentration of nucleophile as well as the concentration of alkyl halide the rate of this reaction will depend on nucleophile as well as the alkyl halide. So the order of reaction will be 2. So that is the reason we call this reaction as SN2. Okay, let's suppose we have CH3 CH2 Br. This basically, this one is bromoethane reacting with potassium hydroxide. Right now I am using dilute potassium hydroxide because I am using water as a solvent. So what I will get CH3 CH2OH substituent product and KBr. Okay, now according to SN2 reaction mechanism, so first I will draw the display formula of this alkyl halide right now. So it will be like this. H here there will be also H will be there. Okay, yes. Okay, now remember that the bromine will be partially negative and the carbon will be partially positive. Okay, now here we have the nucleophile, that is the OH. So now what will happen, the OH as a nucleophile will attack on this carbon. So then what we will be having a transition state. So OH will be connecting with that carbon, just focus on that carbon, and the bromine will be just leaving the carbon. Okay, what other things are attached with this carbon? Now remember that this one is the hydrogen. So I am drawing a hydrogen here and another hydrogen. Let me draw this another hydrogen here, and this methyl group. So I can just draw this methyl group in condensed form. Yes, I can do this. Okay, now this will be called as transition state. Okay, so after the transition state, what we will get our product, that is HOC HCH3 as well as the Br minus. So this is the simple mechanism of SN2, and this is the simple example. Okay, now I will explain SN1 reaction mechanism. Okay, now let's talk about SN1 reaction mechanism. In SN1 reaction mechanism, what is difference, that this reaction mechanism occur in 2 steps. So step number 1, now let's suppose this one, generally I am just writing this one are alkyl halide. Yes. So in the step number 1, what will happen, the ionization will occur. The alkyl halide, basically the alkyl halide will ionize, so the process will be slow. So when it will ionize, and remember that this thing happened by the polar solvent. Basically polar solvent favor SN1 reaction, as I already explain that thing. Okay, now so what will happen? So we will be getting our carbon cation. So that would be a carbon cation and the halide ion. Okay, this was the first step. Now in the second step, what will happen now? In the second step, nucleophile will attack on this carbon cation. Okay, let me draw this carbon cation again. Yes, R2, R3. Okay, now remember that this structure is trigonal planar. So and there is no negatively charged halide in that. So as now nucleophile has a choice. It can come above the plane to attach with this carbon or below the plane to attach with this carbon. So nucleophile will directly attach with this and we will be getting our product. Okay, R1, R2 and R3. Okay, good. Now this is our product. Okay, now let's talk about the few properties of this SN1 reaction mechanism. The number one property that we already know, the reaction is done in 2 steps. Number one thing. Okay, the second thing, if you just do remember the definition of the rate determining step, the definition is simple, that the slowest step of reaction mechanism is called rate determining step. So according to this definition, our rate determining step will be step number 1. And in the step number 1, we can see there is only one molecule is there. That means the rate of this equation or rate of this reaction will be depending on only one molecule. So when we will write the rate law, so rate law will be written in this way. The rate will be directly proportional to the concentration of alkyl halide only. So that is the reason the order of this reaction is 1, and that is the reason we just identify this one as SN1. Now I will give you a real example for this. Okay, now let's suppose we have this molecule. Okay, now you can see this one is molecule. I am reacting with NaOH. So directly what I will get a substitute product, that would be CH3 CH C2H5 OH and NaCl. So now remember that here we will be using a polar solvent. Okay, now what will be the mechanism? There will be 2 steps as I already told you in the step number 1. So what will be happening? Ionization will occur. Okay, now this alkyl halide molecule will get ionized. When it get ionized, so it will be forming a carbon cation. Now you can see this one is the carbon cation along with the chloride ion. Now this carbon cation in the step number 2 will be attacked by the nucleophile. Okay, remember that our nucleophile OH. Okay, first let me draw the carbon cation. Okay, yes, this one is CH3 CH and C2H5. Okay, so here it has positive charge. Okay, now remember that I already told you that this OH, that is the nucleophile, can attack from above the plane or it can attack from below the plane. It has 50% chance to attack above and the 50% chance to attack below. So we will be having 2 different products, 50% of different and 50%. Okay, let me draw this thing for you. So 50% I will be having this kind of product. C2H5, and 50% I will be getting this product. Okay, now what kind of difference you can find in between these two products? Let me write down the percentage as well. So percentage will be 50% here and 50% this way. Okay, if you just compare these two products, and right now I just use this example, both are mirror images to each other, and this carbon is also a chiral carbon. Now one will be maybe a plus enantiomer, and the second will be maybe a minus enantiomer. Maybe it will rotate the plane polars like clockwise, and it will rotate the plane polar anti-clockwise. So if you do remember the stereoisomerism, so you will remember that we will be getting 50% of let's suppose if I'm getting 50% of plus enantiomer, then I will be getting the 50% of negative enantiomer. In short, we can say we will be getting a racemic mixture. Okay, now this was the simple mechanism of SN1. Okay, now let's talk about the comparison of SN2 versus SN1. That what kind of alkyl halide or what condition basically will give us SN1 reaction mechanism, or what condition will give us SN2 reaction mechanism. Okay, remember that when we talk about the type of alkyl halides, so we have normally 4 types of alkyl halide. Number 1 type is called methyl halide. So this one is methyl halide. The second type will be primary alkyl halide. Yes, this one will be primary alkyl halide. Third type will be secondary alkyl halide, and the fourth type will be tertiary alkyl halide. Okay, when we talk about these 4 different type of alkyl halide, so let me give you, this one is primary, secondary and tertiary. Okay, so remember that we will be getting more and more reaction mechanism SN2 when we are using these two, primary and methyl. So primary and methyl alkyl halide normally give SN2 reaction mechanism, and when we talk about the third degree alkyl halide, they mainly give us SN1 reaction mechanism. And when we talk about the secondary alkyl halides, basically they give us both. They basically give us SN1 as well as SN2. They basically now they start depending on the solvent, that what kind of solvent we have. If you will use a polar solvent, then the secondary alkyl halide will give you SN1 reaction. But if you will use less polar or non-polar solvent, then they will give you SN2 reaction mechanism. Okay, now let me give you reason for this, why the type of alkyl halide changes the type of mechanism. Okay, if we talk about SN2 reaction, in the SN2 reaction, remember that the nucleophile always come and it attack on the back side here. So it will always come and it will attack on the back side. Okay, now if we compare the group attached with this alpha carbon, let me identify this one as alpha carbon, this one is alpha carbon here. Now just focus on this alpha carbon. Now you can see, if I just compare only primary with the tertiary, So what difference you can see in the primary, we have smaller hydrogen attached with alpha carbon, but in the tertiary we have the larger group attached with the alpha carbon. So nucleophile can easily attack on this alpha carbon because of the smaller hydrogen group, but nucleophile cannot directly attack on, or not easily attack on this alpha carbon because of the larger group. So this kind of effect is named as steric hindrance. Remember that. Okay, now so that is the reason normally we get SN2 reaction mechanism with primary alkyl halide or methyl alkyl halide, and in the case of third degree alkyl halide we always get, or mostly we will get SN1 reaction mechanism. There is another reason for this, that why third degree alkyl halide always or mostly give SN1 reaction mechanism, and primary alkyl halide mostly give SN2 reaction mechanism. Let me give you another reason for this. This one is primary alkyl halide. So if I ionize this primary alkyl halide, so what I will get? I will get a primary cation. Now this one is primary cation, and if I ionize third degree or tertiary alkyl halide, so what I will get? I will get third degree carbon cation. Now this one is third degree carbon cation. Okay, now this one is the third degree carbon cation. If you just compare both of them, now remember that this third degree carbon cation have this third degree alkyl halide have 3 electron donating groups, but in that we have only 1 electron donating group. So electron donating group basically inductively donate electron to this positive charge, and they try to balance or neutralize this charge. So when this charge get balanced or neutralized, so what will happen? We have a stable carbon cation. So when we have a stable carbon cation, so the thing readily occur. So that is the reason. This is the another reason or second reason. So that third degree alkyl halide mainly give SN1 reaction in which we have the ionization occur. Okay, now let's talk about the elimination reaction. Elimination reactions are also two type. Number one type is called E2 reaction mechanism, and the second type is called E1 reaction mechanism. And remember that they are also named as beta elimination. So why they are represented as beta elimination, I will discuss during the mechanism. So first I will just tell you the general mechanism of this one. Okay, I will start explaining the general mechanism of E2. Okay, in E2 let me draw the general structure of alkyl halide. Now this one is general formula of alkyl halide. Yes, now let's suppose remember that we know that this one is a leaving group, and it could be any halogen, it could be chlorine, bromine or iodine. Okay, now and when we just talk about the carbon that is directly connected with this leaving group, this carbon will be represented as alpha carbon, and the carbon which is connected with the alpha carbon is named as beta carbon. Okay, now if we talk about the inductive effect here, as we know that because of the negative end on the right hand side, right now we have a negative end on the right hand side, so other end will be partially positive. So both carbon will be partially positive. So this carbon will be partially positive, and that carbon will be partially positive. Okay, now you can see I just draw the partial positive charge on the beta carbon more. The reason is that this is the opposite end of this negative. So with respect to this, the hydrogen which are connected with the beta carbon are also partially positive, and they will have higher partial positive charge, or they will have a greater partial positive charge. Now remember that these are beta hydrogen. Okay, when we talk about the elimination, in elimination reaction we have the OH group act like a strong base. Previously I was just explaining that OH is a nucleophile. Remember that whenever we are using a concentrated potassium hydroxide or sodium hydroxide, so it will act like a strong base. Okay, now remember that, the strong base always like to attack on the hydrogen instead of, or partial positive hydrogen instead of the carbon. So what it will do, it will attack on the beta hydrogen here. So it will not, most probably not attack on this hydrogen or from here. The reason is the same, if you do remember. So because of the negative part is here, so let me erase this. So it will attack on this hydrogen here. So when it will attack on this hydrogen, so we will be getting our transition state. So OH will be connecting with this hydrogen and this hydrogen will be disconnecting with this carbon. So all the other bond will remain same. Here, because the hydrogen is removing, the leaving group also start thinking about to leave the alkyl halide. So this kind of state will occur. Okay, now remember that when both the bond will break, this one and that one, the another bond have to develop between carbon to make it alkene. So this kind of state will be termed as transition state. So now what will happen, we will be getting our product, eliminating product. After this we will be getting our eliminating product, that will be alkene. Okay, and what we will getting here along with H2O as well as the halide ion. Okay, now if I talk about type of this reaction, so as we know that this is only a single step, one step reaction, and there are two molecules involved in whole reaction. First is the base molecule and the second is the alkyl halide. This one is the first molecule and this one alkyl halide the second. So rate law will be written in this way. The rate will be directly proportional to the concentration of the base and the concentration of alkyl halide. With respect to this, the order of this reaction will be 2. So that is the reason this is called E2 reaction mechanism. Okay, let me explain now E1 reaction mechanism. The E1 reaction mechanism also occur in 2 steps as SN1. So same case is there. So in the step number 1, the ionization will occur. The ionization of alkyl halide will occur. So let's suppose this one is alkyl halide. I am using a real example right now here. Now let's suppose 2,2 dimethyl chloroethane is the alkyl halide. So first I will ionize this and I will convert that thing in 3rd degree carbon cation. Okay, now this one is 3rd degree carbon cation along with the chloride ion. Okay, in the next step what will happen, so in the step number 2, what I will do, I will just draw this carbon cation in this way. Now you can see what I am doing here. I just expanded one methyl group, but other two I didn't expand it. Okay, now what will happen here, the base, as we are using we are talking about the elimination reaction, so here we will have a strong base instead of a nucleophile. So base will come and it will attack on the hydrogen instead of the carbon. So when it will attack on the hydrogen, so the bond between the hydrogen and the carbon will going to break and the next bond will be developing here. Okay, we will be getting this product. Carbon double bond will form. It will be CH2 and this will be CH3 along with water. Now this one is simple, the mechanism of E1 reaction. Okay, now if I discuss the few properties of this type, so in that type you can clearly see, the whole reaction done in 2 steps. And remember that the first step is also slowest step and also called rate determining step. So the rate law will be written in this way. The rate will be directly proportional to the concentration of the alkyl halide. Remember that only in the slowest rate determining step only the one molecule is there, that is the alkyl halide, so the order of this reaction will be 1. So that is the reason we call this reaction as even reaction. Okay, remember that. Now if you have any type of question regarding elimination or elimination versus substitution or any question, you can comment me. I will answer in the comments. Thank you.